All right, the discriminant. Today we're going to talk about the discriminant. Now the discriminant is just a part of the quadratic formula. Now for us to talk about the quadratic formula, we have to remember the quadratic formula. And what's the best way to remember the quadratic formula? Sing it, that's right. So let's sing it together just to remind us of what it is. 1, 2, 3. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, we remember the quadratic formula. Excellent. Now, the discriminant is just one piece of the quadratic formula. The discriminant is this piece right here. Now, the discriminant gives you some information that can be helpful for figuring out how many solutions or how many roots of an equation you have. So let's take a closer look at this. If you remember back to graphing quadratics, there are 3 different situations for your solutions. Now you could have a quadratic. When you graph it, it's a parabola that crosses the x-axis twice. This would give you 2 solutions because it crosses the x-axis twice. So this has 2 roots. You'll notice I'm going to use the word roots, solutions, and x-intercepts interchangeably. They all mean the same thing. You'll also recall that we could draw a parabola that only has 1 solution, like this. And this parabola has a solution. I'm going to move it up just a little bit to make sure it touches. This has a solution. Now it's green. There you go. And this parabola has a solution right here. It only has 1. The vertex is on the x-intercept. So this will get you 1 solution, or 1 root. Finally, I can also draw a parabola that has no x-intercepts. In other words, it has no solutions. And that would look like this. I could draw one like this as well. It doesn't touch the x-intercept. Therefore, it has 0 real roots. Now, it has imaginary answers, which we'll get into a little bit later. But it doesn't have any real roots. Now, the discriminant will tell you how many roots an equation has. So, if the discriminant, and that would be b squared minus 4ac. If the discriminant is greater than 0, you will have 2 roots, because that's when you get that plus or minus situation, and you have to go to positive and negative land, and you get the same, and you get 2 different solutions. To get 1 solution, the discriminant has to equal 0, because then you just have the negative b over 2a. You only have 1 solution because the square root of 0 is 0, so you don't have anything to plus or minus. And I bet you can't guess what's going to give you 0 roots. If it's less than 0. So if b squared minus 4ac is less than 0, you will get no real roots. And here's why. Can anyone tell me what is the square root of negative 4? What times itself is negative 4? Negative 2 times negative 2 is positive 4. Positive 2 times positive 2 is positive 4. There is no number you can multiply by itself to get negative 4. It's impossible. It's imaginary, even. So there is a branch of mathematics called imaginary mathematics that has to do with using negative square roots. And I'm going on a sidetrack right now. an italicized I stands for imaginary numbers. It is equal to the square root of -1. So the square root of -4 is going to be 2i, because it's 2 times the square root of -1, which is imaginary. Okay, but again, that's a sidetrack there. So I'm going to move on to some examples. So we have question A. And we're going to figure out how many roots it has. And not only that, we're going to figure out if the vertex is above or below the y-axis, or the x-axis. So, could someone remind me, what is the discriminant? Brianna?
B squared minus 4ac.
Okay, b squared minus 4ac. All right, what's our a, what's our b, and what's our c value in this? A equals 1. B equals -3. C equals 4. So let's plug it in. So we have -3 squared, because that's our b value, minus 4 times a, which is 1, times c, which is 4. So if -3 squared is 9, minus -4 times 1 times 4 is? It's -16. 9 minus 16 is? -7. How many roots do I have? 0. So this has no real roots, because we are dealing with imaginary numbers here. And so the discriminant is -7, and we have no real roots. So now let's try another problem. So I'm going to erase this. Let's try another problem. What is the discriminant? B squared minus 4ac. What is our a? What is our b? What is our c value? Oh, Abby, what is our a, b, and c value?
A is 1, B is 4, and C is 5. Or
-5. So let's plug it in. So we have 4 squared minus 4 times 1 times -5. What is 4 squared? 16. Minus -4 times -5 times 1 is +20. So we have 36. So I have a discriminant value of 36. How many roots do I have? I have 2 real roots. Now, I foreshadowed, I said how many? I also said we're going to figure out if the vertex of our parabola, that is the minimum or the maximum, is above or below the x-axis. So since I have 2 roots, I have a parabola that crosses the x-axis. Let's say this is the x-axis. Is this parabola opening up or down? How do I tell if a parabola opens up or down? Jared? By the first term, by the quadratic term. The quadratic term is positive, therefore the parabola is smiling. Therefore, if I have 2 roots and the parabola is smiling, my vertex must be below the x-axis. That's the only way I can get that. So let's try one more. Now you could probably figure out what you're going to get on this example. So the first one, we had no roots. Second one, we had 2 roots. There's a good chance for getting 1 root in this one. What is our a, b, and c value? What are our a, b, and c values? Oh, Eva. All right. And our discriminant, you'll remember, is b squared minus 4ac. So our b value is 20 squared, minus 4 times our a value, which is 25, times our c value, which is 4. What is 20 squared? 400. 400. So 400 minus, what's negative 4 times 25 times 4? 4, oh my goodness gracious, 400 minus 400 is? How many real roots does this have? 1. This has 1 real root. And where is the vertex in terms of the x-axis? The vertex, in order to have 1 real root, the vertex must be on the axis. And that's it. That's all we're doing with the discriminant today.
Yay!